Hi there, welcome to the very first video of Core Java programming series, and in this video we are going to talk about Java introduction and the execution basics. Now, who are the audience for this series? Guys, this is for absolute beginners. Okay, who are absolute beginners? So if you are going to school or college and you have to learn the core Java concept, then you are the right audience for this. If you are working as a manual QA and want to switch to automation and want to explore tools like Rest Assured for API testing and Selenium for UI testing, then you are also the audience for this series. Okay, but the very important question is, should I learn Java in 2021? Now, the answer is simple yes. There are so many different modern programming languages out there that are doing extremely good, and the brightest one of them is Python. There are many who feels like Python is killing Java, but the truth is Java is thriving in big companies. Airbnb is using Java, Uber and eBay are based on Java, Pinterest, Groupon, Spotify, Pandora, Square are based on the Java mostly. Google has a huge percentage of its development in Java. Accenture is using Java for most of its clients. Hardware companies like Intel, Symantec, Philips, Thomson, T-Mobile also uses Java. Also, as the world moves more and more towards mobile apps and convenience, Java is becoming more and more instrumental as a language. The majority of the smartphones and the smart devices have Android as its operating system. Now, Android development is impossible without Java, and it is one of the main reasons why Java is thriving in today's programming world. And if we look at this Google trend for last 2 years, Java is still number two in the list. This yellow line represents Java, right? Python is on top, all right, that's fine because of artificial intelligence and machine learning. It's a great language, but Java is still at number two, guys. With that much of investment right into Java, it is here to stay for at least 10 more years. And if you see the updates of Java, those are not minor updates at all. They take time to release their updates for continuously improvising Java language to adapt to the modern requirements of the industry. Now, what is Java? So, Java is, as per this definition, a platform independent, high level, class based, object oriented programming language that is designed to have as few implementation dependencies as possible. A lot of technical jargon in this definition, right? So, let us break this definition down into individual components like platform independent. Okay, the concept is you write code once and run it anywhere. Okay, then high level is you use English like language to create your programs. Okay. Class based. We cannot write a single program in Java language without first creating a class. And then object oriented. Now Java supports encapsulation, abstraction, polymorphism, inheritance, and all user defined types are objects. Okay. So therefore we say it that Java is an object oriented programming language. Right, fine. But in this video, what are we going to do is we are going to understand platform independence concept and high level concept into detail. In the next video, first I have to install the prerequisites, okay, to run our first program into Java. And when we start the programming, right, guys, so we'll be focusing on class based and object oriented programming. So we will be writing program around all these concepts, okay. So whole series will target all these, okay. Now, platform independent. Now, what is that? Now, before we understand the concept of platform independence, we need to have basic understanding of hardware, operating system, software program, and the runtime environment. Okay, because in here you see I mentioned hardware, operating system window, and in here operating system Mac. Then we have the program. All right, and in here we have this JVM also alongside these three boxes. Right. So what is that? So to write any program, guys, we require some hardware and an operating system. And this diagram is showing exactly that. Okay, so this course targets this program box. Okay, but let me briefly touch base hardware and operating systems too. So hardware includes the physical parts of the computer such as CPU, memory, hard disk, monitor, mouse, keyboard, sound card, graphic card, blah blah blah, etc. Then comes the operating system. Okay, the most important software program in our computer, guys, is operating system. Now, this program manages the sharing of the resources of a computer among processes. The entities running inside the operating system are called as processes. An operating system performs basic tasks such as controlling and allocating memory, controlling input and output devices, controlling CPU time, facilitating network and managing file system. Just imagine without these operations, what is the use of a computer? Okay. Now, next come this program. Okay. So a software program is commonly defined as a set of instructions, or a set of modules or procedures that allow for a certain type of computer operation. Now, process is an instance of a program while it is executed. Okay. That's a difference between process and a program. While a program itself is just a passive collection of instructions, the process is the actual execution of those instructions. The nature of interaction between the OS and the process is about resource allocation. The OS is in charge of managing the computer resources between all the processes it manages. The main resource the OS offers and manages for all processes are, guys, memory, CPU time, disk space, input and output devices. Now, as an example, sometimes a programmer requires access to system resources such as system properties, standard input and output, or the current time, etc. Right? So your program could make system calls directly to the operating system, but then your program would be able to run only on that particular OS. Each time you want to run the program on a new OS, you would have to port your program by rewriting the system dependent section of the code, right? And that is called as platform dependence. Right in here you could see the program is same, but it is running directly on the operating system, and hence we have to make duplicate copy of this, and we have to use the system specific methods and functions. Okay, that's not a great approach. And this problem is solved by Java. Okay, and how did Java solve that? So we created an abstraction. As you could see, we created this Java virtual machine. JVM stands for Java virtual machine, basically, right? That's the acronym of it. This provides us that opportunity to write platform agnostic code, guys. Okay, JVM is a runtime environment which execute Java classes. Okay, look at this diagram. Okay, in here we have dot class file and we also have dot Java file, right? So the JVM simulates basically a complete machine on which Java programs are executed. So when we compile, okay, so in here we have a compiler, right, guys? Understand that these are important concepts basically. So when we compile a Java source file, okay, which is of extension .java, we create a file which contain instructions specific for the JVM. Okay, and these instructions are called as bytecode. The JVM bytecode is then interpreted. So that's how a Java program compiled on any architecture can be interpreted on other architecture, given that an implementation of the JVM for the destination architecture exists. You see, the same code, all right, can now run on Mac, Windows, and Linux, all right? An important point to be noted here is that while Java is platform independent, the JVM is platform dependent. Okay, different JVM is designed for different OS. Okay, so when we'll install JDK, okay, that's another term. So we have said JVM, JRE, and JDK. So we'll see the difference in the next video. Okay, but to install Java right onto your system for development purpose, we are going to install JDK. And when we install JDK, we'll get JRE, we'll get this compiler. and also this JVM machine, guys, right? So we are going to pick our OS specific JDK, right? The next is high level, right? So Java is known as a high level programming language because it can be, uh, you know, uh, read and written easily by humans, as you could see in here. While on the other hand, machine code is also a computer program but written in a language computer understands. It is written in binary 0 and 1 and uses the hardware specific instruction set. Machine code is the lowest level of software. Okay, so other programming languages have to be translated into machine code so the computer can execute them. Okay, so how does that happen in case of Java? So as we discussed, this Java compiler converts this source code into bytecode. Okay, and bytecode is a kind of average machine language. Okay, let's see how it looks. So this is my program, guys. Okay, this is the source code, and then in here you see, I mean, this is how this bytecode is gonna look like. So you have this compiled from hello world.java, okay, and says public class first.program.hello world. But in here, what do we have? We have the class, and what is the name of the package? First.program, and we are going to understand all that into detail. I'm just trying to walk you through this bytecode thing, okay? And guys, what do you see in here? So we have this method descriptor, then you have this stack one, local one, and you have public and hello world. That's the name of the class, and this is bracket, guys. This is a constructor, and this is the first method in the stack, as you could see. So we are kind of loading things into the stack, some kind of stack, and then we have this PC registers. It That's why I said it's a kind of average machine language. Okay, so we have written this code into English language, which is being converted to this by the compiler. Okay, that's a bytecode. But we still have to convert this code into the native code, meaning the zeros and one, which our computer can understand. And where do we execute that 0 and 1? We execute that in the processor of our computer. All right. So guys, this is the next concept then. So JVM, okay, receives the bytecode and convert that into native code. And there are two main components that perform all the jobs to convert the bytecode into native code: class loader and execution engine. So class loader reads the dot class file. All right, guys, the file that is being created by the compiler. All right, which contains that bytecode. All right, we just saw that. So class loader basically reads the .class file and loads necessary files and resources onto JRE. It is responsible for loading, linking, and initialization in order to load, verify, prepare, and initialize the class. Okay, this line: invoke static java.lang system. So these are from different packages, right? So in here we see the reference. Now this class loader is going to actually pick all those things and create one file for us. Okay, then JVM uses actually memory, right, in order to run the program. So that memory area is referred to as runtime data area, which consists of method area, heap, Java stack, PC registers, and native method stack, right? So we saw PC registers, we saw stack, right? We saw native method stack in that bytecode, all right? Okay, so after the code is successfully loaded, the main task, which is the execution of the code, is done by execution engine. This component has interpreter, just-in-time compiler, and garbage collector. Okay, now just-in-time compiler and interpreter together convert the bytecode into native code, which could then run on computer processor. So if you are a performance engineer, okay, understanding the JVM into details will help you in finding performance bottlenecks related to JVM. JVM performance tuning involves trade-offs between many aspects, and one single aspect can greatly influence the overall performance. Therefore, it is required to comprehensively consider all possible influences. Certainly not required for this course, okay, it's just an extra information for performance engineers. Now guys, thanks for watching, and in the next video, we'll install Java, other prerequisites, and write our first Java program. I'll see you there. Thank you.